The Pompeii Worm. 2 miles down on the East Pacific Rise, there's an animal whose tail is sitting in water that would scald a human in under a second. And it does this voluntarily, every minute of its life. It built the most heat-resistant proteins ever found in any animal on Earth. And it had a reason. The Pompeii worm, Alvinella pompeiana, lives in paper-thin tubes glued to black smoker chimneys. The tail sits in vent fluid up to 176 degrees Fahrenheit. The head pokes out into 72 degrees seawater. So really, it's a worm wearing a chimney like a sleeping bag, with bacteria on its back acting as the staff. Most people think the worm's whole body sits in boiling water. Turns out, it's essentially running an air-conditioned tube, pulling cool seawater past its head so only the tail end touches the hot stuff. Boiling water hits 212 degrees. Its tail water hits 176. Its skin holds together at temperatures that would unravel every protein in your body before you finished reading this sentence. It picked the most hostile real estate on the planet, glued itself to the wall, and hired bacteria to handle climate control. Forever. Every animal in this video pays for that address in something. The worm pays in proteins it can never let unfold. The vent shrimp. At depths where no light has ever reached and no light ever will, there's a shrimp that figured out how to see. Not with its eyes. Those are gone. With its back. And what it's looking at would kill it instantly if it got any closer. The vent shrimp, Remicaris exoculata, swarms in the thousands around Mid-Atlantic Ridge black smokers, 11,000 feet down. The eyeless thing is technically a lie. The shrimp carries a rhodopsin patch under transparent cuticle on its back. So basically, somewhere along the line, nature decided eyes weren't pulling their weight, and shoved a heat sensor onto the shoulder blades instead. Bold move. The vent fluid shoots out at temperatures that would dissolve the shrimp in seconds. So it does what desert animals do near a campfire. Stays close enough to feed off the warm bacteria on its own gill chamber, far enough that it doesn't get cooked. A pit viper detects warmth at 1 foot. A thermal camera reads heat at 50 feet. This shrimp senses vent radiation through pitch black ocean by feel alone, like a smoke detector glued to your shirt. It can't see the chimney. It can only feel exactly how close it can get without becoming soup. And feeling exactly that every second of its life is the rent it pays. The giant tube worm. Imagine being born without a digestive system. Imagine deciding the volcano next door would handle that for you. This worm has the fastest growth rate of any marine invertebrate alive, and it pulls off that trick on a diet that includes exactly nothing. The giant tube worm, Riftia pachyptilla, lives clustered around East Pacific Rise active vents, and reaches almost 10 feet in length within 2 years of colonizing one. As an adult, it has no mouth and no gut. Instead, billions of bacteria live inside an organ called the trophosome, doing the digestion. The worm outsourced the entire job. Its bright red plume is packed with specialized hemoglobin that grabs both oxygen and hydrogen sulfide. Both get shipped to the trophosome. The bacteria use the sulfide as fuel, produce sugars, and the worm metabolizes them. An adult human grows about 3 feet from infant to adult over 20 years. A bamboo plant grows 3 feet in a day. This worm grows nearly 5 feet in 12 months on a diet of poison gas. It's basically the gig economy of the deep sea. It's a 9-foot factory floor where management has stopped showing up entirely. If you're enjoying learning about creatures that thrive where nothing else can, I post new animal deep dives like this every week. Subscribing really helps. Thanks. The Marine Iguana. Most animals see lava and run. There's a lizard in the Galapagos that walks straight at it for a reason that has nothing to do with bravery and everything to do with how cold its blood is. The marine iguana, Amblyrhynchus cristatus, lives on Fernandina, on the slopes of La Cumbre volcano. La Cumbre has erupted in 2009, 2018, 2020, and 2024. Once every few years, like clockwork. And the iguanas have been documented migrating toward fresh lava flows, not away. They're the only seagoing lizards on Earth. They dive for algae in cold Pacific water and come out hypothermic, basically powered down. Fresh lava flows hold residual heat for weeks. Walking onto a recently cooled flow is the fastest way back to operating temperature. They're using a volcano like a battery charger. Most people assume marine iguanas avoid the lava out of obvious self-preservation. Reality is the opposite. Tracking studies show them moving toward, not away from, fresh flows. Imagine sitting on a hot car hood after a swim. Now imagine the hood is the planet's interior, 2 months ago. It's the only animal that gets nervous when a volcano stops erupting on schedule. Cold blood, hot rock. The ledger always balances somewhere. The lava cricket. A volcanic eruption sterilizes the ground. Nothing should live there for years. Something always shows up in 3 months, and biologists still can't fully explain how. It can't fly, it has no wings, and it's somehow the first colonist on every fresh Hawaiian lava flow ever recorded. The Kilauea lava cricket, Coconomobius fori, is found only on lava flows from Kilauea and Mauna Loa. Wingless, around 9 millimeters long, showing up on flows as little as 3 months old. And its diet, real talk, is wind-blown debris, sea foam, dead insects, plant fragments carried in by the trade winds. The leading theory is that the crickets are persisters rather than colonists. They survive in lava tubes and cracks under the flow, then re-emerge once the surface cools. Either way, they're eating wind-delivered organic matter on a substrate that until recently was molten rock. The common version of this is that lava crickets eat plants or some kind of volcanic mineral. They eat sea foam. The wind brings them their groceries. A sparrow needs seeds and bugs every day. A desert beetle harvests fog water from its own body. This cricket waits for the wind to deliver dinner across an entire mountain. It's a wingless cricket whose entire diet arrives by air freight. The vent crab. 13,000 feet down in pitch darkness, there is a crab that still has eyes tuned for shallow tropical water it will never see. Its eyes know about a kind of light it has never personally encountered. Its ancestors did, and the wiring stuck. The vent crab, Bythagrea thermidron, is the dominant crab of the East Pacific Rise vent fields, living at 13,000 feet. The bizarre part is in its eye chemistry. Its retina is calibrated for sunlight, which never reaches its adult home. Vent crab larvae develop in midwater at much shallower depths, where there's still some light. They have eyes that work on normal sunlight. Then they descend, find a vent, and live the rest of their life in pitch black. The eye pigments don't fully reset to deep sea sensitivity. Scientists have been studying this for decades, and the best they can do is shrug. A goldfish sees daylight every day. A cavefish loses its eyes within a few generations. This crab kept the wiring for daylight long after its lineage moved into permanent darkness. It's like wearing reading glasses you keep wearing in the bathtub. Its eyes are still optimized for a sunny afternoon 2 miles up. They're never going to see one. The Scaly-Foot Snail. There is exactly one animal on the planet that incorporates iron sulfide into its body, and it lives where the iron is delivered fresh, by the volcano, every minute of every day. Its armor isn't a clever biological innovation, it's almost an accident. And that almost accident makes it the most metallically armored animal alive. The Scaly-Foot Snail, Chrysomalon squamiferum, is found only on Indian Ocean hydrothermal vents, 2 miles down. Its outer shell layer is reinforced with iron sulfide. So picture a snail in a chainmail shirt, except the chainmail is rusted plate metal, and the rust is structural. The mineral isn't synthesized by the snail. It precipitates out of the vent water and accretes onto the soft sclerites covering its foot, same chemistry that produces fool's gold. The vent delivers a constant supply, and the snail's outer surface is chemistry friendly enough that the metal sticks. Most people assume the snail forges its own armor through some magical biological trick. Turns out it grows the soft sclerites and the volcano does the metallurgy. A typical animal heart is 0.5% of body volume. A hummingbird's hits 2%. The Scaly-Foot snail's hits 4%. It's a snail in a chainmail shirt, and it didn't pay for the chainmail. The vent did. But the snail trades skeletal calcium it'll never get back, and that's the price of the suit. The Vent Eelpout. Most fish stay clear of black smoker chimneys. There's one that doesn't, and the rest of the vent ecosystem has noticed. It's not the biggest animal at the vent. it might be the most consequential. The Vent Eelpout, Thermarsis cerberus, is found on East Pacific Rise and Galapagos Rift active vent fields. It reaches over a foot in length, with scaleless white skin that reduces drag in the dense, chemical-laden water. It's the only real predator of vent limpets and amphipods, so basically a keystone predator the size of a baguette. The eelpout feeds preferentially on the largest limpets, which controls the limpet population, which keeps grazing pressure on the bacterial mat stable, which keeps the chemosynthetic food web from quietly tipping over. Take this fish out, and the limpets explode, the bacteria get overgrazed, and the whole structure shifts. A reef shark structures a coral system. A wolf restructures a forest. This fish restructures a black smoker chimney, with no light and no plan B. The limpets have a problem. Take this fish out of the picture, and the whole vent quietly starts eating itself. Out here, every armor plate is a debt someone has to pay. The vent mussel. A mussel on a beach gets one job: filter water, eat what's in it. The vent mussel got bored with one job. It can do what almost every other mussel does, plus a second trick that only volcanoes make possible. The vent mussel, Bathymodiolus thermophilus, forms dense beds around East Pacific Rise vent fields and reaches around 8 inches in length. Inside its gills, it hosts chemosynthetic bacteria that turn vent chemistry into food, the same way the tube worm does. Unlike the tube worm, the mussel never lost its mouth and gut, so when filter feeding is the better play, it eats normally. 2 metabolic pathways, 1 body. Get this, it runs both jobs simultaneously, and toggles toward whichever is more productive. A normal mussel filters 1 liter of water an hour. An oyster cleans 50 gallons a day. This mussel filters water, runs an internal bacteria farm, and toggles between them based on supply. It's the diversified portfolio of the deep sea. Day job, side hustle, and a strategy meeting between the two. Half the human workforce should be taking notes. It's a mussel with 2 streams of revenue and no boss. The Yeti Crab. 6-inch white crab. Ghostly. Completely blind. And it's, somehow, a farmer. It doesn't hunt, it doesn't scavenge, it cultivates. The Yeti Crab, Kiwa hirsuta and its relatives, was discovered in 2005 along the Pacific-Antarctic Ridge at 7,200 feet. It's covered in dense pale setae that look like fur. Bacteria grow on those setae. The crab harvests them as its primary food. A close relative, Kiwa puravita, has been filmed waving its claws over warm vent fluid in slow, rhythmic motions to feed the bacteria oxygen. Picture fluffy white claws like oven mitts, swaying above a chimney like the world's worst conductor. Not foraging, farming. The setae are colonized by bacteria that the crab cultivates, scrapes off, then eats. Not finding food, growing it. The dance keeps the garden watered. A spider weaves a web and waits. An ant farms aphids in a colony. This crab invented vertical agriculture in a place with no sunlight. It's the only crustacean with a crop schedule. 2 miles down, on a smoking volcano, a blind crab is dancing because dinner needs more oxygen. The Pink Iguana. Of every animal in this video, this one is the rarest, and the volcano underneath it's more reliable than its own population. Every individual sits on a single volcanic slope. The Pink Iguana, Conolophus marthae, was discovered in 1986. Around 200 individuals remain in the wild. They're found only on the slopes of Wolf Volcano on northern Isabella Island in the Galapagos, and Wolf Volcano last erupted in 2015 and again in 2022. So technically, the Pink Iguana commute has a non-trivial lava component. Conservation crews monitor the population, but the geology is the variable nobody can control. Honestly, wild that we missed an entire iguana species on a volcano until 1986. A panda population sits at around 2,000 individuals. A vaquita porpoise sits below 20. This iguana sits at around 200, all on a single mountain that occasionally throws lava. Every pink iguana on Earth lives on one mountain that has erupted twice in the last decade. They're still there, for now. The Pompeii worm pays in proteins. The Marine Iguana pays in body heat. The Scaly-Foot Snail pays in calcium. The pink iguana pays the highest rent of all. Survival itself, balanced on the wrong mountain at the wrong moment. If you made it this far, I post new animal deep dives like this every week. Subscribe so you don't miss the next one. Thanks for watching.